Hello everyone, my name is Daniel and I'm a programmer and an artist, and yesterday I released these geometry node assets and I talked a little bit about the Solidify curve node group and how you can use this curve, basically how to do curved mesh but also generate UV coordinates at the same time. And then I kind of briefly discussed a few of them, but I thought today I'd go into more detail about the edge to beams node and how that works and maybe recreate it so you can see how it was made. Usually when you're imagining something you could make with nodes, you have an output in mind. You're like, I want to make a node tree that produces a beam as an output. And then the question is, right now I don't have anything. There's an empty node tree. How am I going to put nodes together so that I get that output? So we start with the output. We have the big question mark. How do we get there? The first thing we have to decide is what are the inputs. So in the case of this beam generator, the inputs are a single edge, or each edge becomes a beam. For the sort of procedural generation node trees, I like to try to make the inputs as simple as possible. So talking about single vertices or single faces, or each edge becomes an element, or you draw an outline of a face and it turns into walls, or whatever it is. The simpler you can make the input, the quicker you'll be able to duplicate and build and reuse it. So this has worked pretty good. It's each edge becomes a beam, and I think if you subdivide it, I've never actually tried to do that, but so yeah, if you subdivide it, it makes a bent board. Anyway, in the case of the beam generator, that's all done using mesh edges. Since I made it, there's a couple drawbacks to it. If your beam's not square and you give it a long side and a short side, then the object orientation determines which sides can be the long side or the short side. So if you want to have some beams on the wall and then some other beams or planks on the floor, you actually have to duplicate the object and rotate the object 90 degrees, which isn't the greatest. Also, this is going to be... maybe that would be a better place since the redo panel pops up there. Anyway, since I made it, I wondered if using curves as the input would be better than using mesh edges, because then you can tilt the curves and you can also scale. You can set the radius of the curves. So the plan today is to remake the beam generator basically the same as what it is right now, but starting with a curve as an input instead of a mesh. So before we get into the nodes, let's go over step by step the operations we want to do with the nodes to go from an edge or a curve into a beam. So we start with 2 points, A and B. We're going to pick a resolution to upsample our edge to. Then we're going to delete some random points because we want to add some variation, but we don't want the variation to be evenly spaced because it looks too uniform. Then we're going to offset all of those randomly by some amount to give some distortion to the beam. And then we're going to solidify it or add dimension to it so that it becomes a 3D object instead of just a spline or an edge. And then along with that, we can create UV coordinates somehow. So that's the big steps we're going to do. Let's get started. All right, so the first thing about using the curves we might want to decide is, do we want to support the evaluated curve or do we want to convert them to points? And that, because the cool thing about using a mesh vertice is you don't have to worry about handles or anything. I think since it's pretty easy to go into edit mode and make the handles vector, it should be allow for some extra possibilities if we let you curve your beam. I guess, so yeah, there could be reasons why that would be useful to be able to do. I do always like to add a resample. I think in this case length is the best option, and then we'll plug that into our input. We'll call it resolution. Then we want to pick a good default value for it. I think 0.25 might be a good starting point. as far as making it into a mesh, we can see we can actually just use the sweep curve, because we can sweep a square across the curve to make the beam. So the way we can do that is we can add a grid with just two vertices, and we can make that a curve. To curve. We can plug that in. If we put a bevel on this, it'll make it look nicer. So interestingly, I hadn't thought about that. One downside of using the curve as the input is that you're limited to only the curve allowable modifiers, but curves can use the bevel, so I guess that's okay. So we'll just do that to make our normals look a little nicer. Let's turn the wireframe on. Now, interestingly, because the sweep curve resamples, the current version of it does anyway, we have more edges than we actually need. So since we have 4 in our grid, we can set the resolution to 4 here, and that will. So then what I did on the mesh version is I resampled to a resolution, and then I deleted some of the points randomly so that you got different spacings between the edge loops, which kind of breaks up the uniformity of the noise. That's a little less useful, perhaps, if you have if you're trying to match a curve. But I'm thinking we can expose how many points get deleted to a slider, and then you can kind of control how uniform that randomness is. That would be an option anyway. So we can add a delete. The cool thing about deleting points out of curves is that the edges of the curve stay connected if you delete a point in the middle. So we can just select a random percentage of these to remove, and we should probably do a endpoint selection. So we want not the endpoint and this random value. And not add. There we go. I was like, why is that floats? So not the endpoint and a random chance. I think a good number is probably like 0.2 or I don't know. But like I said, we can expose that as a input and call it loop uniformity. But then we kind of want it to be the opposite, so we can do a subtract 1 minus that, and we'll make this 0.75 instead. All right, so that gets us our random spacing between our loops. The next thing we want to do is we want to use the perturb group to push the vertices around randomly. And then we can control how much we want to do that. That should go to the input. And we can call this randomness. Oops. Randomness. And the randomness should be like 0.1 or something. Or maybe 0.3, I don't know. Whatever you think looks good. All right, then what we want to do is we want to be able to control the size of the beam. So I think if we go in edit mode, we can already scale it up and down by selecting the whole curve and using the shrink fatten on the curve. But it would be cool to be able to scale them in one dimension. Unfortunately, there's not an easy way to do that in the curve or for each beam that we make. We're kind of have to, I think we have to set that on the group as a whole, and then if we wanted different shape beams, we'd have to have different objects with different settings on the node group. The way I like to do that is by using a radius and then a ratio for how squished it is, essentially. You could also just set the X and Y values directly. That is an option. So the way we do that is we just add a multiply. You have to search for math unless you drag a socket. So we're going to put that into the Y, and then we want a input, and we want to call that input radius. And that radius goes in the X value. And then we want this value to go here, and it's going to be the ratio, which is expressed as a fraction, which is kind of weird, but. So you can see now that we've changed the height, we actually have a problem where the curve sweep node is giving us a bad result. And it's doing that because it's resampling the curve, which I hadn't considered. So let's quickly modify the curve sweep node so that it so there's an option to resample or not. So we can see here in the curve sweep node, you can either connect a curve object or you can do a swept curve, and then those are both resampled. But now we want to add another switch, and we want that switch to be called resample, and we'll put it up at the top by resolution. So first you choose if you resample. If you do resample, what resolution do you want? And then false would be to skip the resample node. Then if we skip the resample node, we need to know the count. So for the UV purposes. So over here where we set the UVs, we divide by the resolution. So we need to do a switch here on the resolution. If resample is true, that's fine. Otherwise we need our curve that we start with. We want a statistic, I think. Or no, we want a domain size of a curve, and we want the curve point count is going to be what we need. So there we go. Now I've added a better option to our curve sweep. So we put this in, we want resample off. That means the resolution shouldn't do anything. That fixed. Back to our radius and ratio. So now one thing is currently the radius is 1/10 because we also have a radius on the sweep curve. So let's make the radius here 1. And that way the value we pick for the radius in our curves to beam node reflects real world sizes. So we can see it's 1 meter tall. Let's make that 0.1 again. And then this should be multiply, not add. All right, so that gets us one step closer. We've got our beam. It has 2 different sides, a tall side and a short side, and we can tilt it in the curve object, which is an improvement over the mesh version because you can't tilt vertices. Now, another thing I didn't do with the curve sweep node is caps. So let's actually go into the curve sweep node, and all we should have to do for that is find curve to mesh and choose fill caps. However, I guess we should check then, we should add a set material, and we should put that to the input so we can pick the material. I think that's fine. And we'll just fix up the UVs here a bit. All right. So one problem we have is that the sweep curve node, I didn't think about doing caps. So the caps aren't UV unwrapped. So let's see if we can add that to the curve sweep UV node and also add another option to use caps or not. So the curve to mesh node is here. So I guess the first thing we should do is we should put this to the input to make that an option. We'll put that up at the top. So then if we do fill the caps, we need to, unwrap them. So I think the way we can do that is we can capture another attribute on the input curve. We can do a Boolean endpoint. Then after we have made it a mesh, let's separate geometry endpoint. Hey, there's our caps. So maybe we actually want to capture an attribute on the face. So that works. Now we have like a mask essentially. All right, so now we have a mask of just the end caps. What we can do is we can create a UV coordinates for them and then add them to the UV coordinates we already made for the beam itself, or the length of the curve. I've been thinking a bit about how the best way to do that would be, and it's a little complicated because we want to be able to support any shape of end cap, and they could be all kinds of different shapes. So I'm thinking the best way to do it is probably just to... So I'm thinking the best way to do it is just to use the UV unwrap node and then give a way to scale the end caps UVs so you can match them to the scale of the UVs for the length of the curve. So we'll try to do that. The way we can do that is we're going to need, here where we get our UVs, we will need to combine two different UV maps together. And we can do that by adding the two UV maps together after we have masked them by this mask we made. So the way we can do that is we can do a scale by our mask, and that will be for our new UV map, which will be an unwrap node. And we want to select just our end caps for that. And then we can scale those UVs by a value we supply on the input. I don't really like this solution. It seems like there should be a way to calculate the scale automatically to match, but I'll have to give it some more thought if there's a good way to do that. So put this under fill caps and we'll call it cap UV scale. So that should work. Then we need the opposite of our mask, so do subtract, we'll do 1 minus the mask, gets us the opposite of the mask. And we want to scale our original UV map by that, which is this, or no, we need to scale. Scale our original UV map by the inverted mask. And so since we have a black and white mask on the end caps, the UV coordinates will get scaled to 0 for the inverted mask, and then on the normal mask, the whole length of the board, the UV coordinates will get scaled to 0, and then we can add them together, and we'll have... Oh, we actually have to use our attribute we captured. Yep, so then we'll have UV coordinates on the end, and then we can control those with this cap scale. I think like 0.6, 0.5 looks like about right for this. So anyway, quick and dirty. You're probably never going to see the end caps anyway, but it's a good example of how you make something, you try to make it general and flexible for all sorts of things, and then you realize that there are use cases you didn't consider and you have to try to adapt the node. Unfortunately, because of how Blender works, now I have this new version of this curve sweep node. Well, luckily it's actually in I'm working in the same file, so it works in this case, but oftentimes you're in another file and getting that updated change that you've made to improve a node back to your assets folder can be a bit of a pain. So I'm just double checking my my original group to see if there's anything else I did. There's I have this option here to subdivide it. I think I did that to smooth it out maybe. I'm not sure why I subdivided it. And then the other one is flip faces, which we can see we do need to do. For some reason, whenever I do curve to mesh, the faces are always inside out, or often inside out. So to fix that, we can just come to the end here and do a flip. Now our faces are facing out, which is good. And then it's already smooth because it was a curve to begin with. So I think that pretty much covers it. Now we've got a beam generator from curves. And we can do vector curves to make straight lines, just like with the mesh. You could also make your curve type to a poly, which gets rid of the handles, which can be nice. I guess that changes that per spline. Then it's a lot like a mesh, but you still, I think you still have, yeah, you can still tilt, which you can't do with a mesh. And you can also scale with Alt-S, which is pretty cool. So I think that's a pretty flexible tool and an improvement on the original version. Hopefully you found this interesting. All of these assets, which I will put back up here again. All of these node groups are available on my Gumroad page for free, or if you want to give me something for them, I appreciate that as well. You can let me know if there's any of these nodes you want me to go into more detail on specifically. A lot of these are pretty simple, like this just adds noise to a curve, but they're useful building blocks. So I'll probably maybe talk about the rope wrap node next, since it's a little bit more complicated. But yeah, if you have questions about any of them, I'd be happy to try to answer them. Anyway, that's it for now. Thanks for watching.